This is Trig Identities, part number 3, and this is a replacement video for the original Trig Identities, part number 3, that I produced a long time ago. Why am I replacing that video? Mainly because it was so dull and so boring and so, well, it was absolutely a piece of junk. That's all it was. And I saw that nobody was going to learn anything from it, so I decided to replace it. Okay, what was I trying to present in that video? Well, what I was trying to show you is how to derive the cosine of angle A plus angle B. Now, where's the complication in this? Okay, we can use the distance formula to figure out the cosine of angle A. That is not a problem. However, because angle B does not start on this 1, 0 line right here, it would be virtually impossible to find the cosine of angle B without my assistance. Okay, so how are we going to do this? Alright, now, what about these Cartesian coordinates right here and right here? Well, as you can see, they're subscripts. Now, I explained a long time ago that when you have a variable, variables are only numbers in disguise. These are actual numbers here. You just don't see them. Okay? These are real live numbers, you just don't see them. And so what we're saying is that this is the first x coordinate, and this is the first y coordinate. This is the second x coordinate, and this is the second y coordinate. That's what we're saying. And if we were to replace those with the actual numbers, you would see real numbers in here instead of variables with subscripts. Okay? And I'll talk about this in greater detail in just a minute. Now you say, well, how are we going to find the cosine of angle B by using the cosine of A plus B? I'll show you that. Alright. As you well know, there are these lines called secant lines. And they join 2 points in a circle, but then they extend outside the circle. Now, what if you want just the segment that's within the circle? Well, then you have something called a chord. The line that connects this point up here with this point down here is called a chord. Okay, and in some previous videos I talked about Ptolemy's table of chords. Well, this is one of his chords. That's what that is. Okay. Now then, once you have that chord, then you can start deriving the cosine of A plus B. How do you do that? First of all, you use what you find in Euclid Book 1. You say, wait a minute, Euclid Book 1, I remember that. And you should. Yes, you can actually duplicate angle B down here. You say, why would we want to duplicate angle B down here? Because then one of the sides, or one of the rays of angle B would be this 1, 0. Then you could derive angle B. Okay? So, we're going to use the properties of Euclid Book 1 to duplicate this angle here down here. Now what are we going to do? Okay, the next thing we're going to do is we're going to draw another chord. And we're going to draw a chord from this point up here to this point down here. And believe it or not, this chord here is going to be the exact same length as this chord up here. Now you say, well, knowing this new information, how are we going to get the cosine of A plus B? We're going to use the distance formula. That's what we're going to do. Okay, so what was the distance formula? Oops. That is the distance formula. Now what we have to do is we have to replace all these values, the x2, the x1, the y2, and the y1, with something else. And we're going to do that in just a minute. Alright. Now what's the first thing you know about unit circles? Well, if you've been paying attention to all my videos, if you've been watching all my videos, you know that a unit circle has a radius of 1. Okay? So that means that this line here is the length of 1. This line here is the length of 1. So is this. So is that. All 4 of these lines are the length of 1. We know that. That's by a unit circle. Now, let's say we wanted to find the cosine of angle A. Well, that's very easy, because all we have to do is find the adjacent side and have it divided by the hypotenuse. It's an adjacent side divided by hypotenuse. That's how you get cosine. Well, to get the cosine of angle A, you can replace the x1 with the cosine of angle A. So now we have your two coordinates. All we've done here is we replaced x1 with the cosine of A. That's all we've done. You say, well, how do we justify that? Because if you take the length of the adjacent side and you divide it by 1, you're still going to have the length of the adjacent side. That's how it works. Let me say that again. If you take the length of the adjacent side and you divide it by 1, which is this, then you have the adjacent side. That's how that works. Okay, now, what's y1? Well, it's actually going to be the sine of A. How do we know it's the sine of A? Because the sine of A is the opposite side over the hypotenuse. Okay. So now what we have is, and I bet you're probably wondering about this, when you drew this chord right here, okay, you formed a right angle triangle. That's what you formed right here. Okay? And that's how you start with all these cosine and sine and that kind of thing. Alright? Now then, what is the sine of A? Well, believe it or not, the sine of A is the opposite side over the hypotenuse. Okay? So we started with this angle right here, which is the adjacent side over the hypotenuse. And now we're going to use the opposite side over the hypotenuse. Well, the opposite side is this, right here. This is the opposite side, and the hypotenuse is 1. So if you have the opposite side divided by the hypotenuse, and the hypotenuse is 1, then the opposite side is being divided by 1, therefore that's still going to be the sine of A. Okay. Now, what are we going to do about replacing these two right here? Okay. Now then, we have to replace them. What were those x2 and y2? Well, I'm going to tell you exactly what they were, and what they still are. So now, Up here you have the cosine of a plus b and the sine of a plus b. Okay. Now then, since we have the cosine of a and the sine of a and the cosine of a plus b and the sine of a plus b, we need to find the coordinates down here. What are these coordinates? Well, I'm going to tell you what those are. They are the cosine of b and the sine of b. That's what those are. Okay. Now that we know all of this information, we can finally find the cosine of a plus b. How are we going to do that? We're going to start replacing values in this distance formula. Okay? Because what we're going to say here is the length of this line right here is equal to the length of this line right here. How do we say that in terms of the distance formula? I'm going to show you exactly how we're going to do that. All right. Hold on. Alright, so first we have to establish the distance of this line right here. Well, the distance of this line right here is going to be the cosine of a plus b, which is your x1 coordinate, and your y1 coordinate is going to be 1, okay, because there's a 1 up here. And then, well, no, that's wrong. That's wrong. Let's try this again. We have the cosine of a plus b, which is your x-coordinate here, and your other x-coordinate is coming from this. Okay? Cosine of a plus b, and there's the 1. Alright. Now, what is the y-coordinates here? What is x2? I'm sorry, what is y2? y2 is the sine of a plus b. That's where we get this from. This is coming over here, and this number is going over here. That's where we get that from. Alright, so now this right here, this equation right here represents this distance right here. That's what that represents. I'm going to bring this just a little bit closer so you can actually see it. Alright, now since we said that this length here is equal to this length here, we now have to give the distance formula equation for this line right here. How do we do that? Okay. All right. I don't like these markers, I really don't. Okay. Glad you were so patient with me. This distance formula equation, let me put one more of those. Let's try that again. This distance formula equation represents the distance right here. Okay. Now, how did we get these values? Well, the cosine of A comes from right here. The cosine of B comes from right here. The sine of A comes from right here. Now then, here's the key. Anything below this horizontal axis over here is negative. Anything below this is negative. So this is actually the negative sine of B. This is the negative sine of B. Okay? So, you say, well, in this one, you had the sine of A plus B minus 0. Down here, you have the sine of A plus the sine of B. How is that possible? Okay, here's how that works. Normally, we would say the sine of A is, you would take the sine of A and you would subtract the sine of B. But the thing is, that sine of B is already negative. And if you subtract a negative, you add a positive. When you subtract a negative, you add a positive. So instead of saying we're going to subtract the negative sine of B, we're just going to add the sine of B. That's where we get that from. So, to review, the cosine of A comes from here. The cosine of B comes from here. Now, why is this a positive cosine of B? Because when you're talking about horizontal coordinates rather than vertical coordinates, okay, this horizontal is still in the positive even though the vertical is in the negative. Sine is a vertical coordinate, so it's in the negative. But cosine is a horizontal coordinate, and it's still in the positive because horizontal coordinates are positive when they're going to the right, and they're negative when they're going to the left. Vertical coordinates are positive when they're going up, but they're negative when they're going down. That's why the cosine of B is still positive because it's going in the right direction, and the sine of B is negative because it's going in a vertical downward spiral. You understand? If you don't, just leave a comment down here below and I'll tell you more. Alright, so the cosine of A right here. The cosine of B right here. So we're subtracting the cosine of B from the cosine of A. And then over here, the sine of A right here. There's your sine of A. It's right here. And the negative sine of B is transferred down here, but like I said, when you subtract a negative number, you're going to add a positive number, so it's the sine of A plus the sine of B. And that's how we get that. So this equation here equals this equation here because this line right here is the same length as this line down here. I know that doesn't look like that in the picture, but that's what it really is if you were doing this the way you're supposed to. And that's how you get the cosine of A plus B. Now in Trig Identities Part 4, we're going to show you exactly how to factor out that equation so that it doesn't look like a pathetic mess. Alright, I will tell you more in a future video. Stay tuned.